Hey students, in this video I'm going to go over how to write quadratic equations in vertex form. So vertex form is the form that needs a letter of A in the front of the equation and then H and K replaced. So A, H, and K are the values that we need to have in order to have an equation that looks like vertex form. So you're going to be given information that is enough to find these values. So for example, these four examples here are practice of given a congruent parabola and a vertex, write an equation. So for example, here are two equations, two parabolas that are congruent. So if you noticed, both of them have that 5, so that's an A value, and that A value has to be equal in both equations in order to say they're congruent. That way they're not too wide or too narrow. So what you want to do is read carefully, and if they want a congruent equation to this, you need to recognize that the A value is 1/2. So this is saying that they need you to write an equation that has an A value of 1/2. Then they give you the vertex. And the vertex is the letters of H and K combined. So we're going to label these two this 3 and -6 as H and K. So H is 3, K is -6. So with these three values, we can write our equation already. So we're going to write y equals A value, which is 1/2. Oh, and another thing is if it opens up or down. So if it's down, you're going to have a negative value. So -1/2 is your A value in order for it to open down and be congruent to this. And then you're going to follow the format. So parentheses x minus, and then your H value. So our H value is 3 squared plus your K value. Our K value is -6, so we're going to put just -6. So this equation is the correct equation. That will be a parabola that opens down and has a vertex of 3, -6, and is congruent to that. We can always graph it to check that that is true. So I'm going to first graph the other equation, 1/2, and then x minus 1, and that's that one. And then we're going to have the one we typed, so -1/2 x minus 3 squared minus 6. And since you can barely see it, I'm going to zoom out. So let's see there. So you notice that they're exactly the same width, just one's up and the other one's down. And this is the one we created. And in order to verify that it has a vertex that is given right here of 3, -6, we're going to trace it. So right there where it says maximum, it says 3, -6, that's the vertex for it. And then it's facing down, and it's the same width, it's congruent to that one because of that 1/2. Okay, so this verifies that this is correct. You don't always have to graph it to verify, but that's an option for those that want to do it. Okay, let's try the next example below. So we have write an equation of a parabola that is has a vertex of 0, 5. So that's your H and your K. HK. And then it opens up, so the A value is positive and is congruent to this one. And the A value here is that 4. So a positive 4. So with that, we're going to use the template. So let me write the template first. Y equals A x minus H squared plus K. and we're going to replace the a, h, and k. So y equals 4x minus 0 squared plus 5. And then you clean it up, you simplify it. So because you're adding 0, you're adding nothing. So you just have x squared. So y equals 4x squared plus 5. That would be the equation. It was simplified, but this would be the vertex form if you write it with the parentheses. Alright, so the next part of the video is explaining how to write an equation given a vertex and another point. So this whole process is what you need to do. You will have to use the vertex that they give you, use the h and k that they give you, and use the x and y value of the point that they give you. So you need 4 values, and you're going to replace these 4 parts with numbers. So when you replace those 4 parts, it will look like this. So the y is 12, a, leave it alone, x is -2, minus h is -6, so it's minus -6, and then plus k, your k is -4, so it's -4. So you basically substitute these 4 parts and then just follow PEMDAS and solve for a. Once you solve for a, then you go back to substituting the values you need to. So again, replace the 4 letters and solve for a, and then rewrite the equation substituting a, h, and k like you did above. So let's practice 3 times right here. We have an equation given, and in order to write a vertex form, we need 3 things: a, h, and k. So the h and k can come from the vertex. So -1, 3. So -1 is your h, and k is your 3. So we just need to find the a. And because we're not given anything else, we need to calculate that a. So pick another point in the graph. Let's say I use this point right here. That's 0, 1. And that will represent x and y. And this will represent h and k. So I'm going to copy down the formula, which is y equals a x minus h squared plus k. And I'm going to replace y, x, h, and k. So the y is 1, and it equals a parentheses your x, which is 0, minus your h, which is -1, squared, plus your k, which is 3. And if we simplify this, I guess I should write these in color just so they can stand out. And if we substitute, simplify this, double negative becomes a plus, and 0 plus 1 is just 1. And then 1 squared is just 1. 1 times 1 is 1, so you have 1a plus 3 equals 1. So 1a is just basically the a, so we need to subtract 3 and move it to the other side. And that results in -2 equals 1a. And again, 1, it could be any number. So if you have a number next to the letter, you just want to divide by the coefficient. So -2 divided by 1 is just -2. And that's your a. So now that we have the a, we can understand that we have all the values we need to write our equation. So we're going to write, again, the template. And now we're going to replace the a, the h, and the k. And the a was -2, so y equals -2, x minus your h, which is -1. So when you put minus -1, it becomes +1. And then the k is +3. So this is the equation for that graph. And you can always graph it in your calculator to verify that. Here's an x1 without a graph given, but enough information to start. So a vertex is h and k, and a point is x and y. So we have the template ax minus h squared plus k, and we're going to replace the y, the x, not the a, the h, and the k. So we're going to replace the y with an 8, and then the x is a 1, your h is a 2, and your k is a 5. So then we clean it up. PEMDAS 1 minus 2 is -1 squared. And then -1 squared is -1 times -1, which is +1. A times 1 is just a. And then subtract 5. So 3 equals the a. So now we have the a. We can use the a, h, and k to write our equation. So for this, we're going to now replace a, h, and k. So y equals the a value, which is 3. X minus your h is 2, squared plus 5. And this is the final answer. This is the correct vertex form equation for the given. And again, at any time, you can always double check by typing this in your calculator. I'm just going to show you this example. So if I graph 3 parentheses x minus 2 squared plus 5, I'm going to trace it. And I'm going to check that the 0.25 is there. So if I keep going to the right, I can check that minimum is 2.5 and the 0.18. If I cannot get the exact number, I can always type 1, enter, and it goes to 1.8. So that confirms that this equation creates a graph that has those 2 points. All right, last problem here, we have an equation given the vertex form. And they give you the axis of symmetry, the maximum, and the y-intercept. So here we have a point, that's your x, that's your y. We could use this to annotate what the vertex is. So picture a graph that has a y-intercept at 0, -9.5. It has an axis of symmetry when x is -3. And it has a maximum of -5. So -5 will be, let's say, somewhere here. So it's going to look something like this. It has a maximum, it's opening down. This vertex is created by that value and that value. So -3, comma, -5. That's your vertex. So I can put -5 right there. And this is your h, and this is your k, and this is your x, and this is your y. So you're going to substitute those values in here for y, x, h, and k. We're going to write -9.5 equals your x is a 0, minus your h, which is -3 squared, so minus negative, it's a plus, and then your k is -5. So to solve for a, we're going to add 0 plus 3, which is 3 squared, a in the front, -5, And then we're going to do exponents, which is 3 times itself. So 3 squared is 3 times 3, which is 9. And then you're going to have 8 times 9. So that just becomes 9a minus 5. And then you have to solve for 8. So plus 5 equals negative 4.5 equals 9a. And then you're going to divide by 9. So a equals, let me just use the calculator so you can see, negative 4.5 divided by 9. That's negative 0.5. Negative 0.5, or you could also just say negative 1/2 is your a. So since that's your a, and this is our h and k, where is it? Right here. So let me just write on the side. A is negative 1/2, h is negative 3, k is negative 5. We're going to use those three values to write our equation. Y equals a x minus h squared plus k. And we're going to replace a, h, and k. Y equals negative 1/2, x minus negative 3, so that's positive 3, minus 5. So this is the equation for this scenario. Okay, I hope this video helps you understand this.